So let's start out just talking a little bit about a radical. So a radical is this sign that you see right here. That's a radical sign, okay? If you see it by itself, it means square root, okay? If you see it like this, that means what root? That means the cube root, okay? So real quick, you know, so the square root of 4 is 2, square root of 16, 4, and 5. So you know how to take the square roots of numbers. Cube root of 8. What number can I multiply 3 times and get an 8? 2. Cube root of negative 8. What number can I multiply 3 times and get a negative 8? Negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Remember, when you multiply, an odd number of negatives gives you a negative, an even number of negatives gives you a positive. Cube root of 27 is what? 3, because 3 times 3 times 3 is 27. Now, some of this we'll hit in this section, but some of it is just a review. When we see square roots, we're going to need to know what the opposite operation is of a square root. So let's just take, for example, you know some of these. What's the opposite of addition? Yeah, that's just subtraction, okay? And it stands the reason that the opposite of subtraction is addition. So this is when you're solving an equation. If something, you know, if 1 is added on one side, you subtract it. You undo that operation. What's the opposite or the inverse operation of multiplication? Yeah, division. So if something is multiplied by x, you can divide by x to undo that. What is the opposite of taking the square root? The opposite of taking the square root of a number is what? Squaring it, okay? So squaring the number, okay? The opposite of taking the cube root is what? Cubing the number, okay? What's the opposite of squaring a number? Taking its square root, okay? The opposite of division is, you know that one, multiplication. And the inverse of cubing is to take the cube root, okay? So these are things that we have to know the inverse operation to solve equations that involve these operations. So let's start with a fairly straightforward one. I want to solve the square root of x equal 5, okay? What is it you don't like when you look at that equation? Pardon me? 5 is not a perfect square, but when you look at the equation, what makes it look harder than the ones we've done? The square root, okay? So what we want to do, we want to get rid of the square root, okay? The way I can get rid of a square root, what is the inverse operation of a square root? Squaring. So the way I solve this is I square both sides of this equation. Okay? So what happens when I have the square root of x and I square it? What do I get? Not x, so the square root of x squared is what? It's what? The square root of x squared. Not 1. These operations are opposites of each other. If I take the square root of something, it's x. Like take 25. What happens if you take the square root of 25? What do you get? 5. Okay, square root of 25 is 5. What happens when you square 5? You get 25. These operations take you back and forth from the same destination. So the reason I square it, if I square the square root, I just get x equal 25. Okay, I square both sides of that equation, and I get x has to be 25. Okay, so that is the solution for this one. Now, in the last section, when we talked about rational expressions, we talked about there was a restriction that we could never divide by what? 0. Okay, so there are only 2 kind of restrictions we're ever going to talk about in this class. One is you can't divide by 0. The other one is dealing with square roots. You can't take the square root of what kind of number? Negative numbers, okay? So these are the only 2 kind of restrictions. What we're going to say in our class is you cannot take the square root of a negative number because it does not have real numbers. If you get in different math classes, you can get into complex numbers, but we're not going to get that deep here. So when you see a negative number, you can't take the square root. Think about it. The square root of negative 9. Is there a number you can multiply by itself and get negative 9? Well, it can't be 3 because 3 times 3 is 9. It can't be negative 3 because negative 3 times negative 3 is 9. So you can never take a number and multiply it by itself and get a negative number. You'll always get a positive number. So when we see square roots in our problems, we have to be concerned that we can't take square roots of negative numbers. So let's look at this example that you see here. The square root of x plus 1 equals 7. So the square root of x plus 1 equals 7. What you just need to be in the habit of looking at is whatever is under that square root sign. I can't take the square root of what kind of number? Again, what is it? Can't take the square root of a negative number. So it tells me x plus 1 has to be what kind of number? Can't be negative. It's got to be positive. So x plus 1 has to be greater than or equal to 0. That's the only way this is true. Because if it's less than 0, this is undefined. So x plus 1 has to be greater than or equal to 0. That means x has to be greater than or equal to what? Negative 1. Okay, so that is my restriction on a square root problem. Okay, so there are only two kind of restrictions we are ever going to talk about in here. You can't divide by 0, and you can't take the square root of a negative number. Okay, that's it. There will be no more other restrictions we're ever going to talk about. How do you know which restriction applies? Like in this problem, how did you know my restriction was dividing by negative numbers? What was your clue visually when you look at this problem? You see it starts with an F. There's a fraction, okay? That's when you look at this, the restriction is I can't divide by 0. How do I know my restriction here is a different restriction? What do I see that clues me off? The square root sign. When you see a square root, you know that what is under there cannot be negative. The way we write it cannot be negative, it has to be greater than or equal to 0. So now I'm going to go find an answer to this, and the answer had better be greater than or equal to negative 1. Okay? So how do I find the answer to this? What do I do to both sides of this equation? You square it. What happens when you square the square root of x plus 1? You get x plus 1. So x plus 1 equal. What happens when you square 7? 49. What does x have to be equal to? 48. So x equal 48. That is the answer to that problem. Okay. Is 48 bigger than negative 1? Yeah. So I have not run afoul of any of my restrictions. Okay. So again, the process for these radical equations is you're going to have to raise it to a power and then go from there. Now let's look at this one. What I need is the square root needs to be all by itself. Okay. Is the square root by itself on one side of the equation? Yeah, it is. Okay. Now let's determine the restriction. To determine the restriction on a square root, look at that. That number cannot be what? Cannot be negative. The way I write 3x minus 5 cannot be negative is like this. That's how I write 3x minus 5 cannot be negative. Okay? So again, I'll just write that. 3x minus 5 cannot be negative. The mathematical way of writing that is 3x minus 5 greater than or equal to 0. That means that 3x is greater than or equal to 5, or x is greater than or equal to what? 5/3. So that is my restriction. Okay? So 3x minus 5 greater than or equal to 0. 3x greater than or equal to 5. Solving this for x, x is greater than or equal to 5/3. So that is my restriction on this problem. Since this is a square root, I will solve it by doing what to both sides? What's the opposite of square root? Squaring. I will square both sides of this equation. So I'll come down here and I'll have 3x minus 5 equal 5. I square both sides of that equation. The reason I do that, it simplifies the left side. What is the square root, what is the square root of 3x minus 5 squared? The left side. Yeah, it's just 3x minus 5. That's why I do that. That's why I square it. If I cubed it, that wouldn't do anything. But when you square a square root, you get what you started with. So this is going to be 3x minus 5 equal, what happens when I square the right side? 25. Now I just solved this. If I add 5 to both sides, 3x equal 30. And then what? X equal 30 over 3 or 10. Okay. No, just x equal 10 is fine. So however you get there. Okay. And I know that x has to be greater than 5/3. 10 is greater than 5/3. So I'm good to go there. Pardon me? So 3x minus 5 can't be negative. So 3x minus 5 has to be greater than or equal to 0, which means 3x has to be greater than or equal to 5. I added 5 to both sides. Solving that for x. X is greater than or equal to 5/3. Now you want to get in the habit for these problems of checking your answer. Okay, you're going to run into a certain situation sometimes where you get two answers and one works and one doesn't. So I want to be able to check my answer. So I've got 3x minus 5. That was my original problem, right? What did I think the answer was? I said 10. So let's check x equal 10. Okay. So I'm going to have 3 times 10 minus 5 equal 5. What's 3 times 10? 30. 30 minus 5. Yeah, does the square root of 25 equal 5? Yes. That answer is good. Okay. Now, if you get one answer, chances are it's going to work. Okay. Where you're going to need this process is when you get two answers. You're going to need to double check and make sure that they both work. Okay. Let's do another example. We'll do this one real quick. The domain restriction. I know that x plus 2 must be what? What kind of number? Yeah, greater than or equal to 0. Okay, so if x plus 2 is greater than or equal to 0, then x has to be greater than or equal to negative 2. To solve this, what do I do to both sides? I just square both sides. And I get x plus 2 equal what? 16. Therefore, x is equal to what? 14, which is a number greater than or equal to negative 2. So I'm good to go there. Now, we get into a problem that's a little bit harder here. We're going to do the same process, though. I want to make sure that the square root is by itself. Yes, sorry, okay. Pardon me? Oh, okay. What I was doing here, it's always a good practice to check your answer. So go to the original problem. If x is 10, just plug in a 10 and see if you get a true statement. Okay. Where this is really important is if you get two answers. We're going to have a few in a minute that come up with two answers. And one answer will work and one answer doesn't work. I want to make sure the square root is by itself. I've got that, okay? So it's by itself. So 6x plus 7 has to be what kind of number? Positive number, okay? That means that 6x has to be greater than or equal to negative 7, or x has to be greater than or equal to what? Negative 7/6, okay? That's my restriction here. Anytime I have a square root, my restriction is what's under that square root has to be greater than or equal to 0. Now I just square both sides of this equation. What happens when you square both sides of that equation? What do you get on the left? 6x plus 7. What do you get on the right? When you square x? X squared. Okay. Now this problem's a little bit harder. Okay. This is a quadratic. We have methods for solving that. I want that to be equal to what? 0. Okay. Now here's the deal. What I need to do is I need to move this over to the other side of the equation. Why didn't I move the x squared over from the right to the left? I would get a negative x squared, and you don't want to factor with that. You don't want to factor with a negative x squared. You want to factor with a positive x squared. So I get 0 is equal to x squared minus 6x minus 7. How do I factor that? I look for two numbers that do what? Multiply to negative 7, add to negative 6. So this is why we spend a lot of time factoring, because factoring just pops up in the course of solving this problem. What numbers will do this? 1 and negative 7, right? So that means that this is what? 0 equal x plus 1, x minus 7. That has to be that, okay? You could have the 0 on the other side, yeah. Yeah, once you get to here, I think you're used to seeing it like this. That's the same thing, okay? Doesn't matter. So what is my solution here? Negative 1, positive 7, right? Now, here's the deal. I've got to check both of these answers, okay? So let's go back to my original. My original was the square root of 6x plus 7 equal x, okay? Anytime you get these numbers, you've got to check them to make sure that they're right with the square root problems. So let's plug in a negative 1. So 6, all I'm doing is say 6. I'm plugging in a negative 1 plus 7 equal negative 1. Okay? All I did was plug in a negative 1 for x. What is 6 times negative 1? Oh, sorry, there's a square root there. 6 times, it's negative 6. What's negative 6 plus 7? 1. Square root of 1 equal negative 1. What's the square root of 1? 1. Does 1 equal negative 1? No. What do you think that means? It means, okay. All I'm doing is, I have proposed that x equal negative 1. So I go back to my original equation, and everywhere I see a x, I replace it with a negative 1. That's next, okay? So I plugged in a negative 1. When I plugged in a negative 1, I got this statement, 1 equal negative 1. What day of the week is that true? None of the days of the week. So that is not a solution, okay? Now let's just, for posterity, to make sure, let's check x equals 7. So I'm going to plug in a 7. So is the square root of 6 times 7 plus 7 equals 7? What is 6 times 7? 42. What is 42 plus 7? So is the square root of 49 equal to 7? That means does 7 equal 7? That is true. This is my only answer. Okay. So anytime you come up with two solutions in these square root problems, you must go back and check it. Okay. So there's a term called extraneous solution. And what that means is, in the process of squaring both sides of that equation, we changed the equation and we got two answers, but they did not satisfy the original equation. Okay? So that's one of the big things. When you square both sides of an equation, you've got to go back and check to make sure if you've got extraneous solutions. What I want to do, let me see how many I've got left. I've got that one, and I need to get to a cube one, okay? So let's do this one real quick. Make sure that the radical is all by itself. So for example, if this problem started out like this, okay, I can't square both sides, okay, because I need the square root to be by itself. So if it started out like this, I would have to get it to x plus 2 equal x. You want that square root all by itself. To find the restriction, you look under the square root, and what does x plus 2 have to be? It can't be what? It has to be, it can't be negative, okay? So x plus 2 has to be greater than or equal to 0. That means that x has to be greater than or equal to what? Negative 2. Now to solve this, I have to square both sides of that equation. What do I get on the left side? X plus 2. That was the whole purpose of squaring it. What do I get on the right side? X squared. Now I've got a quadratic. The way we solve a quadratic is we get it set equal to 0. So if I subtract x, subtract 2, I get 0 equal x squared minus x minus 2. If you are preferred to write it, you can write x squared minus x minus 2 equals 0. In order to solve this, I need two numbers that do what? Multiply to negative 2, add to negative 1. What numbers do that? Negative 2, positive 1. So that means this is x minus 2, x plus 1 equals 0. So according to this, what does x equal? Yeah, well, positive 2, negative 1. I think I'm done, but I'm not done. What is the last step for these problems? You have to check the answer to make sure that both of these solutions work. You can probably tell for many of these, it's the negative one's going to get you into trouble. So let's look at what was the original? It was square root of, what was it? Square root of x plus 2 equal x. So let's check x equal 2. When x is equal to 2, I get the square root of 2 plus 2 equal 2. Square root of 4 equal 2. 2 equal 2. That is all good, right? Now let's check negative 1. So when x equal negative 1, I get square root negative 1 plus 2 equal negative 1. What's negative 1 plus 2? 1. So this is the square root of 1 equal negative 1, square root of 1. So this is 1 equal negative 1. When is that true? Never. So this is not, that's not a solution. Your only solution is x equal 2. Okay? Now, I'm not going to spend a whole lot of time with this, but what's happening here is that's my original equation. When I square both sides, this is the equation that I solved. So this equation has two solutions. This equation only has one solution. So the only way you can find that is to go back and check your answer. So by squaring both sides, you introduced another solution. Now, all of those have been square roots. Let's look at this one. What's different here? Cube roots, okay? I don't have restrictions on cube roots, okay? Because square roots, I can't take the negative numbers, but cube roots, I don't have that restriction. Because remember, we said the cube root of negative 8 is what? Negative 2. So you don't have that restriction. So there are no restrictions, okay? There are no restrictions on the cube root problems, okay? I want to isolate, how can I get this by itself? How can I get that cube root by itself? Yeah, first step, add 3 to both sides. So I get the cube root of x plus 1 equal 3. Now, I am not going to square both sides of this equation. Why am I not going to square both sides? It's a cube root. What am I going to do? I'm going to cube all sides. So I've got the cube root of x plus 1 cubed equal 3 cubed. What is the cube root, cube root of x plus 1 cubed? On the left. Cube root of x plus 1 cubed. That's x plus 1. It looks complicated, but it's not. So if you cube root something and then you cube it, those are inverse operations of each other. And then on the other side of the equation, what is 3 cubed? That's 27. To solve this, you subtract 1 from both sides. X is equal to what? 26. And we're there. Okay? And this one, it says check your solution. You can do that, but you really don't need to in this case. What you can do is just check it to make sure you're right. So what was it? It was the cube root of x plus 1 equal 3. So I'm saying x equal 26. So the cube root of 26 plus 1 equal 3. What's 26 plus 1? 27. What's the cube root of 27? 3. Does 3 equal 3? Yes, that's the right answer. Okay? Oh, sorry. So again, the big things in this section are you're going to have problems that have a square root and a cube root. I don't think I'm going to get much higher than that. If I had the fourth root, what would you do on both sides? You'd raise it to the power of 4. If I had the fifth root, you'd raise it to the power of 5. Okay? You want to isolate whatever has that radical and then raise it to the appropriate power. Okay? What have we got left here? Is there how many problems? Where am I? Just that last one? Okay, and we're done. Do you guys want to work on this one? You want me to help you with it? Okay. Why don't you guys try this one? Can we have one other thing to do here? So, the restrictions. I find that by looking under the square root, because what's under the square root cannot be negative. How do I write cannot be negative? Like that. That's what I mean. It cannot be negative. That means 3x greater than or equal to negative 4, x greater than or equal to negative 4/3. The reason we write this down is when we get to the next unit, we're going to have to do something with this. We need to write it a different way. Okay, so I want you to get used to there are only 2 domain restrictions we will ever talk about in this whole class. You can't divide by 0, and you can't take the square root of a negative number. That's it. Okay, so anytime I'm asking you for restrictions, it's one of those. How do you know which one to use? How do you know it's the square root one when you look at the problem? What do you see? A square root sign, right? How do you know it's the divide by 0 and you see a what? A fraction or denominator. That's how you can tell the difference between the two. Okay, so to solve this, what do I have to do to both sides? Yeah, I square both sides of this equation. What do I get on the left? X squared. What do I get on the right? 3x plus 4. That was the reason you squared it, to get rid of that square root sign. So I want this to be equal to 0. X squared minus 3x minus 4 equals 0. I'm back to a quadratic. We spent many times with this, and it's going to keep coming up. I need 2 numbers that do what? Multiply to negative 4 and add to negative 3. What numbers will do that for me? Yeah, 1 and negative 4. So this becomes x minus 4, x plus 1 equals 0. So I think that x equal 4 or x equal negative 1. Before you think you are done with any of these problems, you must do what to your answer? Check your answer. So it was what 3x plus 4 equal x. Let's check when x is equal to 4. So 3 times 4 plus 4. So 3 times 4 is what? 12. 12 plus 4 is 16. Square root of 16 equal 4. That means that 4 is equal to 4. That's good. Okay. Let's check negative 1. So 3x plus 4 equal x. If I check negative 1, I get 3 times negative 1 plus 4 equal negative 1. What's 3 times negative 1? Negative 3. Negative 3 plus 4 is 1. So this says the square root of 1 equal negative 1. Square root of 1. So this says that 1 equal negative 1. That is never true. So this cannot be a solution. On a problem on a test like that, I just need to make sure that you know that's the only solution. You can circle it and make it clear, or you could write, this is the only solution. Make sure that I know that you no longer think that's a solution. Yes. Okay. Yeah, so you'll be able to do that. So guys, real quick, radical equations. This is what we did today. You want to isolate the radical on one side of the equation. So for example, if I had something like this, the square root of x plus 1, what do I need to be all by itself? I need that to be all by itself, right? How can I get it all by itself? Before I square it, I would need to add 1 to both sides. So I get 2 square root of x plus 1 equal 1. Okay. Now to get it by itself, I can divide everything by 2. I need the radical to be all by itself. Then I can square both sides. Okay? Because now when I square this side, I get an x plus 1. That's what I mean with the square root has to be all by itself. And then you will square both sides of this equation if it's a square root. You will cube both sides if it's a cube root. You have restrictions when you have a square root. What's under the square root has to be greater than or equal to 0. And then when you get to your answer, the final answer, you want to check and make sure that answer works, okay? So you're not going to run into that when you cube both sides of an equation. But when you square both sides of an equation, you could run into a solution where you get 2 solutions and only one of them works. So you've got to check that.